Hello everyone, welcome to another video on root finding methods. And as we said in the previous video, that here we are going to include two special cases. So the first case is what happens if the value is less than 0. So if the user provides a value which is less than 0, what do we do? If it's less than 0, we say that what we do is basically update the value as the absolute value of the value. So absolute value of the value. So if the value is -5, this function will change the value of -5 to 5. So then even if the user provides a negative value, it will still work. So here we call this the value must always be positive, because the square root of a negative number is an imaginary number, so this is not possible to compute. So that's one case here. Then the second thing that we want to do is basically look into the case where the value is between 0 and 1. So what happens if the value is in between 0 and 1? So for example, if the value we want to compute, if the value whose square root we want to compute is 0.5, in that case the square root of 0.5 will be, say for example, square root of 0.5 is 0.707. So as we understand, if it's 0.707, in that case if we set the lower limit to 0 and the upper limit to 0.5, our binary search will never even find this thing. So we need to somehow modify this thing. So the way we do it is, if value is less than 1, in that case what we do is basically we set the lower limit and upper limit to be something different. We set the lower limit to be the value, so in this case it will be 0.5, and the upper limit is 1. Now it works for both the cases. And then there is one other thing that we want to do is so what if the value is 0 or 1? Although it works in our cases, but we still want to specify this thing because we don't really want to go through this loop if we already know the answer to these cases. So what we do is, if value is equal to 0.0 or value is equal to 1.0, in that case we simply return the value. So we simply return value. So if we run this code, well, there is another function that we need to change, which is over here, the square root. So what we do is here we copy paste some of the things, which is, if the value is always positive, the value must be always positive. So first change this, and then we change how we initialize the guess. So we say that if the value is between this, in that case we say upper limit is equal to value, or we say upper limit is equal to value, lower limit is equal to value, upper limit is equal to 1. And in such case what we have to do is we need to somehow update these two things. So for this to work, we say that double guess is equal to 0.0 and upper limit is equal to value, and if this is the case, the guess is going to be value, and the upper limit is going to be 1. Upper limit is going to be 1, and so we change it here. We say that let's change this to lower limit. Lower limit is equal to 0, upper limit is equal to this. And we say lower limit is equal to value, upper limit is equal to 1, and we change it here. Guess is equal to lower limit, and guess is equal to less than or equal to upper limit. And now if we run this code, let's wait, let's control R, let's wait. So for 5 it works as before. Now let's see if it works for something less than 1, so 0.5, and we see that with using, like, the linear search routine uses 2001 steps to find the answer, whereas the binary search uses 4 steps to find a better answer. What we need to add a little bit here, well, there is something that we need to add for consistency, is if the value is 1 or 0, we can just change the code over here for the square root and we put it here. So if we run this code now, if we provide 0, the answer is 0. If we run the code for 1, the answer is 1. So it seems that our binary search and our linear search routine both works for negative values, for values less than 0, for values like 0, value like 1, and any number in between. And we see the linear search is okay, it finds the result. However, the binary search is better. And in the last video from this section, we are going to implement a special algorithm which computes the square root even faster than the binary search. It is based on something that was designed decades, I think centuries ago, by someone, Heron from Alexandria, and we are going to implement that square root concept. Thank you.